All right, we're in chapter 7, and this is section 7.5 on complex fractions. All right, so what our objectives are is to introduce the complex fractions and then simplify the complex fractions. What is a concept fraction to start with? Well, it's a rational expression that contains fractions in its numerator, denominator, or both. So a complex fraction involves division of fractions, and then when dividing two fractions, we can basically multiply the numerator by the reciprocal of the denominator to simplify. So simplifying these basic complex fractions. So if we have any real numbers a, b, c, and d, a over b divided by c over d is basically multiplying by the reciprocal, so a over b times c over d. Now, another ways to write this is we have a over b divided by c over d, and then we know we multiply a over b times the reciprocal, and that's what we have. Now, if we want to look at it going this direction, we could also say, well, let's multiply by d over c, and whatever we do in the denominator, we have to do in the numerator, because then if we do this and this, we end up with 1 in the denominator, and so we end up with this. And so whether we do it like this, we do it like this, we just go directly to this, we always end up with, the A over B times D over C, no matter which direction we went and did it. Now the key is B, C, and D all have to be non-zero because they're going to be in the denominator at some point in time, and so they have to be non-zero. Now, two methods to do this. Starting here is method one. So to simplify a complex fraction, we're going to perform the following steps. First, write the numerator as a single fraction, then write the denominator as a single fraction, and then what we're going to do is we're going to divide the denominator into the numerator by multiplying the numerator and the reciprocal of the denominator. So basically, we're going to keep the initial numerator the same, multiply by the reciprocal of the denominator, and then we're going to simplify if possible. All right, so what we have here is basically we're going to multiply by 3 over 2, multiply by 3 over 2. That becomes 1. And now we have this over this. Well, 3 will go in here once and go in here twice, so we get basically 5 over 4. Okay, now what about here? Again, we're going to multiply by 15y squared over x, multiply by 15y squared over x. That cancels that, that cancels that, so we get 1 in the denominator. And up here, well, that x cancels that y cancels one of those y's. 5 will go in here twice, 5 will go in here 3 times, so we have 3 times y all over 2. Okay. Now let's see how the book would explain this. Well, they're saying, well, we're dividing by that, so if we multiply by the reciprocal, then we have cancel, we get 5 over 4. And they're skipping some steps. They're not showing that if you take this 3 goes in here once and it goes in here 2, 2 times 2 is 4. So they're kind of skipping some steps, whereas I was showing all the steps here. Now here in the book, they're going to multiply by the reciprocal directly. Now again, I think they skip the steps. They just give you the final. Oh, they don't. They actually multiply it out here. So now it's 15xy squared over 10xy. And now you have to reduce. And so when you reduce, you end up with a 3y over 2 because, that x cancels that x. That y cancels one of those. 5 goes in here twice. 5 goes in here 3 times, and you get your 3y over 2. So again, depending on what you're reading in the book, it can go multiple ways. But, this is one way to do it how I'm showing. This is another way. And then again, they sometimes skip a few steps. So if you're not seeing how they got that, really what they should have got was they should have got on this one. 5 times 3 is 15 over 6 times 2 is 12. Now we have to think about, 3 goes in here 4 times, 3 goes in here 5 times, so we get 5 fourths. Okay, so that's kind of what they did here. Whereas here they did multiply it out, and then after that they reduced it, but they didn't again show the reducing step. All right. So here we're supposed to simplify and write our answer in lowest terms. So let's go through how the book would do it because there's not enough room for me to show you how to do it here. So first things first, we're going to get a common denominator here. And so we'll have 3n over 3n on this one to multiply. Here we're going to have to multiply by 3n over 3n as well. And so when we do that, 3n times 3n is going to be 9n squared over 3n. And again, on the denominator, it's going to be the same thing. Now we have a 9n squared minus 1 over 3n. And then the denominator will have a 9n squared plus 1 over 3n. Then we're going to multiply by the reciprocal. So we're going to multiply by 3n over 9n squared plus 1. And so that's what we do here. Now our 3n's cancel, and we get 9n squared minus 1 over 9n squared plus 1. Now, they say, okay, well, we're done here, but sometimes, you have to think about, can you factor numerator and denominator? Well, that's 3n plus 1 and 3n minus 1. Now we get down here, we can't actually factor that one. And so really we are done at that point. But if we could have factored that one, then we needed to do that. But since we can't, then we're actually done at that point. So sometimes factoring it one more step is a key thing. They're not showing that they've thought about it. They just say, okay, well, we're done at that point. All right. What about this one? Well, here we're going to have to multiply and get a common denominator. So we're going to have to multiply this one by x minus 2 over x minus 2, and this by x plus 2 over x plus 2 to get the common denominator, x plus 2 times x minus 2. Now here we're going to have to multiply by x minus 4 over x minus 4, and this one by x plus 4 over x plus 4. And then we're going to get what? X minus 2. And then we'll have here a minus x minus 2. Down here we'll have a 2x minus 8. Here we'll have a minus 2x minus 8. And so showing all of that, we keep going down. And so they kind of show what we've done here. Now they haven't showed multiplying it through yet. But when you do, you're going to get 2x minus 8, and then a minus 2x minus 8. So that gives us a minus 16. Here we have x minus x was 0, minus 2 is minus 4. Okay, now we multiply by the reciprocal. And now we say, oh, well, hey, that 4 will go in here once. It'll go in here 4 times. And now we have just the x plus 4 over x minus 4. And then we have 4 times x plus 2 times x minus 2. And that is going to be our final answer because nothing can reduce at that point in time. And so we would be done. All right. Now let's stop here and we'll start method 2 in the next one.